Healthcare data is growing very fast. We must learn to understand it well. Practical skills are more important than ever. Learning by actually doing things helps us most. This is true for everyone in healthcare, from clinicians to researchers. We need to use real tools and real methods. This essay will guide your learning journey. We will focus on developing reusable, real-world data workflows. This hands-on approach is crucial for true mastery in this evolving field. Imagine taking messy, complex patient records. You then transform them into clear, useful insights. This is our main goal here. This transformation requires very specific data handling skills. We are talking about creating robust data pipelines. These pipelines take raw, often confusing information from various sources. They systematically turn it into something valuable for making critical decisions. This structured process is absolutely vital for modern healthcare. It supports better patient outcomes and operational efficiencies. FHIR is a key part of this entire process. FHIR means Fast Healthcare Interoperability Resources. It is a special modern standard. It helps exchange healthcare information electronically between different systems. FHIR allows different computer systems, software applications, and devices to talk to each other seamlessly. This interoperability is crucial for creating truly connected healthcare systems. Understanding FHIR, its structure, and its implementation is essential for anyone working in health informatics or health data science today. We will explore how to work with FHIR data in a hands-on manner. This journey we are embarking on is not just about reading theory from a book. It is fundamentally about building real, practical, and applicable skills. You will learn to create useful data workflows from scratch. These workflows are designed so they can be used many times over. They are specifically developed to solve actual common problems. These problems are frequently encountered in various healthcare settings today. The main focus is always on practical application of knowledge. This means using the very same tools and techniques that professional data teams use daily in their important jobs. So, what exactly is a FHIR pipeline? Think of it as a special dedicated pathway. This pathway is specifically designed for handling healthcare data effectively. Raw healthcare data, often in diverse formats, enters at one end of this pipeline. This initial data is frequently complex and can also be quite unorganized or incomplete. The pipeline then processes this data through several carefully orchestrated steps. It cleans the data to remove errors. It transforms the data into a consistent format. It structures the data logically. This meticulous preparation makes the data ready for detailed analysis. This entire process ensures high data quality and ultimate usability. It is fundamental for good evidence-based decisions. FHIR data often comes in a widely used format called JSON. JSON is an acronym that stands for JavaScript Object Notation. It is a very lightweight and efficient format for data interchange between systems. It is specifically designed to be easy for humans to read and understand. It is also straightforward for humans to write when necessary. At the same time, machines find it very easy to parse and generate JSON data. Working confidently with JSON is therefore a core skill in modern data handling, especially with web-based APIs. We will see how FHIR resources, like a patient resource or an observation resource, are clearly represented in JSON. This understanding is the first practical step. Querying logic is essentially about how we ask specific questions of our data. How do we efficiently get the precise pieces of information that we need for a particular task? Once healthcare data is stored and available in a FHIR server or repository, we must have ways to retrieve it selectively. FHIR defines a RESTful API, application programming interface, for this exact purpose. This well-defined API allows us to search for very specific information within the data set. For example, we can construct a query to find all patients who have a certain diagnosed medical condition, or we can retrieve all laboratory observations for one particular patient over a specific time period. Learning these FHIR query patterns is vital. It is absolutely essential for effective and targeted data extraction from FHIR compliant systems. The journey from raw, often siloed data to truly useful and actionable insights is genuinely fascinating. It is a significant transformation of information. It typically starts with a thorough understanding of the source systems where the healthcare data originates. Then, we carefully extract the necessary data elements, often using FHIR standards and APIs. We meticulously transform this extracted data into a more usable and consistent format for analysis. Finally, we load this prepared data into a system that is designed for querying and analysis, such as a database or a data warehouse. This whole sequence is very often called an ETL process. ETL is an acronym that stands for extract, transform, load. Mastering this data flow unlocks the immense power and potential hidden within vast healthcare data sets. It directly allows for better, more informed decision-making across all levels of healthcare. Building an entire ETL pipeline might sound quite complex or even daunting at first. However, we can simplify this task significantly by breaking it down into manageable stages. We always start with the crucial extraction phase of the process. Tools like Postman are extremely helpful and user-friendly at this initial stage. Postman allows us to easily send specific HTTP requests to a FHIR server. We can use it to thoroughly test our data queries and see how the server responds. We can immediately inspect the JSON data that the FHIR server returns. This direct, hands-on interaction with the API is crucial for gaining a genuine understanding of the data structure and server behavior. It helps us refine our data requests for better, more accurate results, and it builds our confidence. Python is a wonderfully versatile and remarkably powerful programming language. It is very widely used and highly regarded in the field of data science and analytics. Python can be used to automate the entire data extraction process from FHIR servers. We can write clear, concise Python scripts to fetch FHIR data systematically and repeatedly. Special, well-documented libraries available in the Python ecosystem, such as and help parse JSON data with great ease and efficiency. We can then use Python to transform this retrieved data according to our specific needs. For example, we might select only certain important fields from the FHIR resources, or we might need to combine data elements from different related FHIR resources. This stage is where precise data shaping and preparation truly happens. The transformation stage of the ETL pipeline is absolutely critical for data quality. Raw FHIR data, while helpfully standardized in its structure, might not be perfectly ideal for direct analysis or visualization. It often needs further refinement and careful preparation. We usually need to clean it thoroughly, handling missing values or inconsistencies. We might need to convert various data types, such as dates or numbers, for consistency across the data set. We might also need to create new, derived information from existing fields to provide more insight. Python scripts are excellent, flexible tools for performing these detailed data transformation tasks efficiently and reliably. This stage ensures the data is accurate, consistent, complete, and truly relevant for its intended analytical use. It meticulously prepares the data for the final loading step. Finally, after the successful extraction and thorough transformation, we load the processed and cleaned data. This loading destination could be into a structured relational database like PostgreSQL or MySQL. It could potentially be into a much larger, more scalable data warehouse designed for big data analytics. Or, for simpler cases or specific downstream uses, it could be loaded into a flat file format such as a CSV, separated values file, for more straightforward use with other tools. The key achievement here is that the data is now structured, organized, and validated. It is clean and well organized. It is fully ready for efficient querying, in-depth analysis, and insightful visualization. Building this entire pipeline, even a relatively simple one, provides immense practical learning and a deep sense of accomplishment. It clearly shows the complete data journey from raw source to actionable insight. Foundational analyst tools are absolutely essential for any effective data work in healthcare. Google Sheets is often a great and accessible starting point for many individuals. It is widely available through any web browser. It is also remarkably easy to learn and use, even for those who are beginners with data. You can easily import data into Google Sheets, perhaps from an exported CSV file. You can then perform simple calculations, sort and filter data, and create basic charts very quickly. This initial exploration helps in understanding fundamental data patterns without much technical overhead. It is a good first practical step before moving on to more complex, specialized analytical tools. It builds essential confidence and basic familiarity with handling data tables. Looker Studio, which was formerly known as Google Data Studio, represents a logical and powerful next step in data visualization. It is a robust and free tool. It allows you to create dynamic, interactive, and live dashboards. These dashboards can connect to a wide variety of different data sources, including Google Sheets, SQL databases, and many others. They can be configured to update automatically as new data becomes available, providing near real-time insights. This capability is extremely powerful for monitoring key performance indicators and important trends over time. Visualizing data effectively helps to communicate complex insights clearly and persuasively to diverse audiences, including clinicians and administrators. Learning to build informative and engaging dashboards is a highly valuable skill for any data analyst or health informatician. It truly makes data understandable and actionable. SQL, which stands for Structured Query Language, is truly fundamental in the world of data analysis and management. Once your transformed healthcare data is loaded into a relational database system, SQL is the primary language you will use to interact with it. You can use SQL commands to select very specific columns of data from tables. You can filter rows based on precise conditions that you define to isolate subsets of data. You can also join multiple tables together based on common fields to combine related information from different sources. SQL is effectively the universal language of databases used across industries. Knowing SQL well, including writing efficient queries, opens up vast possibilities for comprehensive data analysis, detailed reporting, and robust data management, especially within the complex and data-rich healthcare domain. The practical skills you develop through this structured, hands-on process are directly and immediately applicable in many roles. You are learning to build genuine, real-world data workflows, not just theoretical constructs. These workflows are designed from the outset to be reusable and adaptable to new requirements. They can be modified and extended for many different healthcare scenarios, research questions, and operational challenges. Building a personal portfolio of such completed data projects is very important for career development. It clearly and tangibly demonstrates your practical abilities and problem-solving skills to potential employers or collaborators. Continuous improvement and a commitment to lifelong learning are absolutely key in this rapidly advancing field. The world of healthcare data, analytics, and technology is always evolving. Keep learning, keep exploring, and keep practicing with actual industry standard tools.